How do we do domain? Well, domain is like a problem, right? The domain of my toaster would be, a toaster's a function, right? The domain of my toaster would be the things I'm allowed to plug into my toaster. There's certain things you're not allowed to plug into a toaster. You shouldn't put knives in a toaster, right? So that would not be in the domain of a toaster. That's what we're doing with these functions. There are certain things you should not be able to plug in. So you want the denominator to not be 0. Remember, that's the big craziness. We can't make denominators 0, right? So we say, okay, denominator, you can't be 0. I don't know if you can see right now. There's no way that denominator is going to be 0. If you can see that right now, you can say the answer is anything's fine. Now, if you can't see that, go on and do some steps to see that. But what am I talking about? Well, think about it. How is this ever going to be 0? Pick any number you want for x.
0.
Plug in anything. 0 is the lowest thing you could put in, because if you put in a positive or negative number, squared, it's going to be positive, right? Lowest thing you could do is plug in 0 there. Times 9, so any number other than 0 you plug in, is positive or negative, is going to be positive after being squared, times 9, and then add 7. So the lowest this part's going to be is 0 if you plug in 0, then add 7. The lowest this thing's ever going to be is 7. It's going to be 7 or more, isn't it? It's never going to equal 0. So if you just see that, just go, that was a silly question. There's no way this denominator is ever going to be 0, no matter what you plug in. It's going to be 7 at the lowest. So there's no way to make the denominator 0, so there's no problems. So the answer is anything's fine. That's what that means. All numbers are fine. Now, I could be more formal about it. If you don't see all that right away, you could just say, well, I'll just try to solve this. How do you solve x squared equations? I don't know if you're familiar. There's two strategies. Let me make it really clear. If you have x squared and x to the first, we did a lot of those yesterday, right? First step is about getting a 0, and then you try to factor. And if it won't factor, you can use, I could say, or use the quad, negative b plus or minus the square root of b squared minus 4ac all over 2a. That's how you solve when you have x squared and x to the first. But if you just have x squared and no x to the first, like we do, excuse me, I'm going to sneeze, I think. Excuse me. Okay, so if you just have, thank you, x squared and no x to the first, see how we don't have an x to the first here? We just have x squared in numbers. You don't have to work quite that hard. It's easier. You can just get x squared alone, and then step 2, put a root and a plus or minus root. Got to put a plus or minus root over the sides, and you're done. It's quicker. You don't have to mess around with 0 and factoring. So you could just do that. Just move that 7 over. So 9x squared not equal. It's a not equals equation. Same thing as an equals, basically. Negative 7, right? Because when it jumps over, it changes sign. Divide by the 9. So x squared not equal to minus 7/9. Good so far. And now, now finish it off by putting the root over both sides and plus or minus outside, because there's two possible options for x squared, right? It can be positive or negative. So anyway, what's the square root of a negative number?
Nothing. Unless it's a jumbo I.
It's imaginary. It's not real. Right? You can't have the square root of it. Square root of any negative number is imaginary. You remember that? You know what I'm talking about? Like square root of negative 9. You can't do that, huh? It's not 3, because 3 times 3 is not negative 9. It can't be negative 3, because negative 3 times negative 3 would not be negative 9 either. You can't mix and match. You can't take one negative, one positive, because the square root asks for the same thing twice that makes the number, right? So it's not possible. You can't take the square root of any negative number. It's imaginary. So as soon as we see this negative inside the square root, we just stop and go, oh, that's imaginary. That can't be. So what does that mean about my answer? Well, if I say, okay, guys, I want you to think of, let me try to make it real. I want you to think of a number in your head, okay, right now. But wait, I got one rule. Don't think of an imaginary number. You're like, okay. So any real number's allowed then, right? That's exactly what our answer is. You see, it's just saying x cannot be imaginary. Okay, so it can be anything real. Right. So same answer. Make sense on that? It's all about that name. Now, if that wasn't negative, if you know that had been positive, you know, then that would have been a real restriction. I would have said, okay, it can't be plus or minus the square root of 7/9 if it had been positive, you know. And I would have said anything else is okay, but not plus or minus the square root of 7/9. But it came out negative in a root, so it's just imaginary, so it can be anything real. Okay, so try that one. We got 5x over x squared minus 9. So try that one. Same thing. We don't even care about the numerator, do we? Everybody good with that? You remember how we do domain? And maybe it'd be good if I wrote that up again. Domain, here's the problem areas. Number 1, denominators cannot be 0. And number 2, if you have a square root, you take out the inside and you say inside, you have to be greater than or equal to 0, right? Because like we just talked about, you can't have a negative in a root. Otherwise, I'll say otherwise, if it doesn't have one of those two problems, then otherwise it's negative infinity to positive infinity. Otherwise, everything's okay. So that's how we're going to handle all of our domain questions. You getting the big idea? Domain can be such a weird thing because, like, what are we really doing? We're finding out what are allowable inputs, what we're allowed to plug in, like I was saying with the toaster. Put in anything you want, but don't put silverware in the toaster, right? Microwave oven, put anything you want, but don't put plastic that can be melted or tinfoil, right? That'd be the domain of those functions, what's allowed to be plugged in. So that's what we're doing. When you look at a function, you really just look for two problem areas. We say, look, denominators can't be 0. We can't have that. And we can't have negative inside of a root. So that's why we said greater than or equal to 0. Because that means not negative, right? If it's greater than 0, it's positive. If it's equal to 0, it's 0. So it's greater or equal to 0 means it's not negative. So those are the two problem areas. No negatives in roots, no zeros in denominators. Otherwise, we're good to go. Otherwise, anything goes. Plug in anything you want. Okay, so we look here and we say denominator, you cannot equal 0. I don't even care about the numerator at all. It's not even a problem. No problems up there. So I say, all right, got to solve this. How do you solve it? You could factor, or you could just move the 9 over and then just put the root on. And you know it's got to be plus or minus, right, when you do that, because there's two options, plus or minus 3. Squared would be 9, right? So x is, or cannot equal, plus or minus 3. So that's the answer. Now, they want me to give it an interval notation, it says right there. So how do you write that in interval? Maybe I don't know if there's room here. It says you cannot be negative 3, and you cannot be positive 3. But everything else is okay. You can be 2.9999. You can be negative 4, negative 2, negative 1, negative 2.99, negative 3.01. Those are all fine. Just not 3 right on the money, not negative 3 right on the money. Because if you plug in 3 or negative 3, it's going to make squared will be 9, minus 9 will make that denominator 0. Huh? It'll choke the function. You can't have 0 in the bottom of a fraction. We talked about that, right? Can't have 0 in the bottom of a fraction. It's undefined. It's not in the real world. Okay, so what does that mean? How do you say, will you say all these numbers are okay? All the numbers before negative 3? That means everything from negative infinity up to negative 3 is okay. Everything between negative 3 and positive 3 is okay. And everything from 3 to infinity is okay. So we say, if I can have a little bit of room to write that out, can you see it if I scribble it out down there? So from negative, well, here, let me just go up top. So the final answer then would be from negative infinity to negative 3, united with, the U just means connecting different sections, from negative 3 to positive 3, and then from 3 to infinity. Parentheses on all those, never a bracket. Because if you do the bracket, remember that has the straight edge, that means you're straight on that number, and that's exactly what we're saying we're not. We're not straight on the negative 3 or the positive 3. We're just close to them, but we can't be right on them. So this is a way of saying every number from negative infinity to positive infinity, except never on the negative 3 or the positive 3. There's always parentheses by them, so we're never hitting them right on. Is that good? That's the domain. That's the allowable inputs. Okay. So we have the square root of 4x minus 36. So see what you can do. I just wrote out the instructions for how you handle square roots, right? What's allowable or not allowable inside of a square root. So we say inside you have to be greater than or equal to 0, meaning not negative, huh? Remember, we can't let any x be plugged in that would make the inside of that square root negative. For example, if I plugged in like 8, that would be bad, because 4 times 8 is 32, minus 36 would make square root of negative 4, wouldn't it? And that's imaginary. There's no number times itself that's negative 4. It doesn't exist in the real world. So I'm just doing a for instance, right? That's not the answer. But I'm just showing certain things are going to cause a problem and certain things are okay. How do we find them? Well, we say inside, you've got to be bigger than or equal to 0, huh? Not negative, in other words. So, okay, so take 4x minus 36, solve it greater than or equal to 0. By the way, what if this was 1 over? Or anything, blah, 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 anything over. What if that was in the denominator? What if that square root of 4x minus 36 was in the denominator? What would I change about this statement? Do you know?
You wouldn't make it equal to, you just make it greater than.
Very good. I'd get rid of that. Because if you're I'm changing the question because it's going to happen in a minute. So I'm preempting it. Yeah, because remember, if you're also in if you're in a square root, you're greater than or equal. But if you're also in the denominator, then you can't be equal, right? You can't be equal to 0 if you're in the denominator. So you would get rid of the equals part. Exactly. We'll do that in a minute. But anyway, this one's not a denominator, so I don't have to worry about that. It's greater than or equal. Equal is actually okay in this case. So solve that. How do you solve it? Just bump the 36 over. Divide by 4. Greater than or equal to 9. They want interval notation, so on a number line, right, that's 9 to infinity. So 9 to infinity. Always a parenthesis next to infinity, right? Bracket at the 9 because you're right on the 9, huh? Equal to the 9. Good? Be happy so far? I aim to please, much as I can. Other than just getting rid of all the hard problems. Denominator. There, so 5x over square root of x plus 4. Try that one. Find the domain on that one, the allowable inputs. So we say inside, you've got to be greater than or equal to 0, but then we go, oh no, not equals though. Because it's a denominator. Is that making sense? Denominators can't equal 0. So it's just greater. So it's x plus 4. You have to be greater than 0. You can't be equal to 0 because you're a denominator. And you can't be negative because you're in a root. So you have to be strictly greater than 0. So then just jump that over. So x is greater than negative 4. So interval notation, put that in number line. That's going to be parenthesis negative 4 to infinity, huh? I'll just leave it that way. We good on that? All right, I'm going to keep moving. There's just so many problems to do in so little time. All right, let's try this one. They want me to subtract those functions. So they're saying f minus g of 1 part A. F, let me just write them up here, the f of x function is 8 plus 4 over x, and the g of x function is 4 over x. Okay, they're similar. Okay, we good so far? So it's saying f minus g with 1 plugged in. That's what that notation says. I want to try to help you kind of speak function a little bit better. So it's say subtract the two functions and then plug in 1. That's not times 1. Right, you aware of that? Parentheses in a function don't mean times. That's really important. They mean plug in, right? So, right, if I have, let me do it for instance. If I have 8 plus 1, and I go, that does not mean f times 3. That doesn't mean take this whole thing and multiply by a 3. That's not what it means, huh? It means stick a 3 right there. Right? So let's be really clear and set our minds, because things are going to get really ugly in just a second, like I was helping somebody after class, and that's exactly was his confusion, so it made me think about saying that again. Parentheses in a function don't mean times. They mean plug in. So they mean plug it into the toaster, right? So this means subtract it, make a new function out of the old 2, a subtraction of the original 2, and then when you got that new function, plug a 1 into that toaster, that new toaster you've made. That's what that's saying. Okay, so let's do that. Let's take the f function and let's subtract the g function. Good so far? That's f, take away g, and it's obvious what happens, huh? So the new function, and I haven't plugged in the 1 yet. I've just subtracted the functions. It's just 8, right? They just subtract, it's just 8. Now it's time to plug in the 1. Okay, I did. There's no place to put it in. The x's are gone, so the answer is just 8. Does that make sense? If there's no x, then throw away the plug-in. It's like a toaster with no holes. Right? There's no place to plug in the 1, so it's just 8. Is that okay? That makes sense? Now, part B says, so that's part A. And then part B says, divide the 2 and plug in a 4. I'm just looking right here. Divide the 2 functions. Instead of subtracting the 2 original functions, now divide the 2 functions. Make a new function out of the old 2, dividing them. So I put the 8 plus 4 over x over 4. So that's f over g. And then plug in. Oh, yeah, we can't. Good question. Yeah, we can't. Do you know we can't cancel these? That's real. I'm glad you brought that up. It's a really good question.
I thought they look like different terms.
Yeah, it's because of that plus sign. Yeah, let's talk about that for a second. I'm glad you brought that. Really important, especially as you move forward to calculus. It's exactly the kind of stuff I want to be helpful to you about. Pluses and minuses. Way I tell my algebra students all the time is pluses and minuses. They like glue things together. You ever shopped at Costco? Sam's Club? We have 5 kids, so my wife shops at Costco. Buy in bulk, right? You go there to Costco, you grab one milk, you pull it out, it's plasticed to another one, right? You can't bring your scissors to Costco. You just cut the plastic. Say, thanks, I just want one. Right? That's the whole deal. You buy in bulk. Well, that's what pluses and minuses are like in algebra. Pluses and minuses glue things together, make them a package deal, which means if you want to, which means these 2 in the top are glued together. Pluses and minuses do that. So that means if you want to cancel anything in the top, you can go like that and buy the whole package, or you buy nothing. You can't say, well, I just want the 4 over x. It's not allowed. Now, if that was times, you could totally do that. The difference is the plus or minus. Does that make sense? It's pluses and minuses that do the gluing in algebra. If it was times, yeah, I would totally just cancel those 4 over x's out of there. But the plus wrecks it. Pluses and minuses is what makes algebra hard. It's all the they do all the hard stuff is because of pluses and minuses in algebra. Yeah, I'm glad we brought that. Please ask that stuff. That is always so helpful to all of us. Okay, anyway, back to it. So, real important to know, we can't cancel those. We have to leave it just like it is. So what do we do now? Plug in that 4, huh? So plug in that 4, right there and right there, right? Good to there so far? Yeah, it's just going to be 9 on the top, right? 8 plus 1, and 1 on the bottom. So the answer is 9. Okay, 4 over 4 is 1. 4 over 4 is 1. 8 plus 1, 9 over 1, 9. Is that good? So we made a new machine, the F over G machine. We plugged in 4. So again, this doesn't mean times 4, it means plug in 4. Put 4 in the toaster, right? That's the same thing, into the course, we're going to review trig, which you guys have had trig, right? It's the same thing. A lot of students get confused with sine, cosine, tangent, and you put something like a pi over here, And they'll sometimes multiply it. It never means multiply. It always means plug in, doesn't it? Those are all function notations. That causes students in calculus a lot of trouble when they're thinking multiply. It's always plug in. All those things are functions. Sine, cosine, tangent, logs, exponentials, these things, everything pretty much is functions. And what comes after a function in parentheses is a plug-in, not a multiply. Not a multiply on that. All right, that's why if you have sine of pi over pi, for example, you can't cancel those pi's. Because that's not times. This is a different reason. This isn't the Costco reason. This is because that pi is in the toaster. Now, if he was in the front, yeah, cancel him. Then he's just a multiplier. But if he's in the parentheses afterwards, he's plugged into the function. That's like f of pi over pi. You can't cancel those pi's. One of them's in the toaster. Right? So it's that way you want to think as you look at these kind of things. Those are functions. All right. Too much tricky stuff in this section. Okay. Yeah, let's answer the domain question. Really pretty tricky here. So the domain, they're asking me, okay, that new machine, the F minus G machine, what's its domain? So I skipped over that. I found the plug-in answer was 8, but I didn't do the domain. Okay, now, what is the F minus G machine? Well, right here, F again, remember, is 8 plus 4 over x, and G is, put it over here, is just the 4 over x, and so F minus G is 8 plus 4 over x minus the G, which is 4 over x, like that. So that's F minus G, and of course, you all know exactly what happens as those drop out, and it's just 8. So now, if I asked you, what's the domain? Remember, domain is you're looking for what cannot be plugged in, like not putting silverware into a toaster. We're looking for two problem areas, right? Denominators, you can't plug in anything that makes the denominator 0, or square roots, anything that would make inside of a root negative is not allowed. So looking at that, well, he's just 8. He doesn't have any denominators. He doesn't have any square roots. Anything goes. Yeah, if it was just 8. And I know it was 8 after simplification, but originally it was that. So here's my point. When you do domain, must use original before simplification. You know what I mean? You must look here. I know it simplifies and becomes 8, and that's a fine answer for plugins and everything. But for the domain question, yeah, I wrote it, domain. For the domain, you have to realize this is really the creation. That's really the new function. Even though it cleans up a bit, this is really what it is right here. Well, so what? Well, he has a problem. He has something you can't plug in. What can't you plug in? Well, you can't make his denominator 0, so x cannot be 0. So that's the answer. X cannot be 0, which is what the answer is over there. Do you see why? You might think, yeah, but it drops out. It's just 8. Yeah, but I know it simplifies, but it's really there. It really is there. So you can't plug in 0 because it'll choke that denominator. It'll choke before it simplifies. If you put in 0 here and here, you can't say, well, yeah, 4 over 0 minus 4 over 0 just goes away. No. No, 8 plus 4 over 0 minus 4 over 0 is not 8. It's craziness. Because this isn't 0, it's craziness. It's choke. So it can't be 0. So are you getting the moral of the story? The moral is this. If you answer a domain question, if you're putting two functions together to make something new, adding them, subtracting them, multiplying, dividing them, whatever, you're making some new creation out of two functions, and they ask you the domain of the new creation, you've got to look at it before it was simplified on that. Yeah?
So it has to be a real number before we can simplify it?
Has to be...
It has to be a real number before we can simplify it, like you said.
I'm just saying you have to look at what you've got before you do any simplification. You got to answer what the domain is on this, not on this, because the 8 is after simplification. So you got to do because the domain of just 8 would just be anything, right? If somebody just say, "Hey, 8, what's the domain?" We'd say negative infinity, positive infinity. But I've got to look up here before it was simplified. I got to answer the domain because that's what it really is. Even though it cleans up, it's really this though.
So look at the original setup.
Look at the original setup. For domain, that's just for domain. So for domain, you've got to look at the original setup to answer the question on that. Okay, so what are they asking me to do here? This is, let me just say, will be on exam number 1 for sure. No secrets with me. I want you to know what I want you to know. Absolutely super important, because the second thing you're going to do in calculus. That's my job here, is get you ready for calculus. This is called the difference quotient. It's done a ton of in chapter 3 in the calculus book. Is that? So it's called the difference quotient because it's a difference, it's a subtraction on the top, and it's a big fraction, a big quotient. So they're calling it the difference quotient. They're calling it the subtraction fraction, in other words, is what they're saying, right? Which sounds like a kind of a lame name, but it is the subtraction fraction. It's the one used for, it's the derivative, basically. It's what you'll do in kids, though. Yeah. So anyway, how do you do it? What is it talking about? Well, let's make sure the language is making sense for you. This is saying take the function and plug in x plus h to the toaster. And then when you're done, subtract x plugged into the toaster, and then divide the whole thing by h. That's what they're saying. This is 2 plug-ins to the toaster, subtracted, and then h divided. What's the toaster? Right here. It says here's your toaster. F of x is 9x plus 8. So anything you put into the toaster is going to slide right there, isn't it? That's what that notation really means, right? Input slot there slides down here, right? Anything you plug into this toaster, you're going to multiply it by 9 and then add 8. That's what that machine does to anything you plug into it, right? And they're telling us, put x plus h into that machine, see what you get out, and then put x into that machine, see what you get out, and then subtract those results, and then divide it all by h. That's what they're saying. So let's do that. So first off, I'm gonna say okay. Here, let me just do it in blue. What is the x plus h? So I'm going to put x plus h into that machine. Minus, now I'm going to put just x into that machine. I'm going to divide the whole thing by h. Is that making sense so far? Everybody see what I did? Right here I put x plus h into the input slot. Right, I put x plus h into the toaster. Went right here. Like good? So all of this, including the plus 8, is f of x plus h, isn't it? Minus, right, they told me to do f of x plus h minus f of x minus, and all of this is f of x. It's just the original function, 9x plus 8. But why do I have to have parentheses? So I got to subtract all of f of x. If I didn't put those parentheses, I would only be subtracting the front part of f of x. And this formula says subtract all of f of x, doesn't it? So I got to subtract all of f of x.
Parenthesis helps with distributing them.
Which means you got to distribute, right? Exactly. We good so far? So then this is got to distribute, so we get 9x plus 9h plus 8 minus 9x minus 8 all over h. Good so far? Let me give you a big hint that'll help. All non-h terms cancel out. Always. When you're doing the difference quotient. See how the only term left on the top is the one that has an h in it? That'll always happen. If that doesn't happen, you messed up. It's a good double check for yourself. All the non-h terms should drop, right? 9x, do you have an h, buddy? No, he's got no h. He better drop out. He did. A 9h, he's got it. He's got an h, so he's okay. He can hang around. 8, you got an h, buddy? No, he's got no h. He better drop out. He does. So if ever you're trying to leave behind a term, if I had like 9h plus 7, the 7 just stayed. No, you messed up. Only h stuff is going to stay every time. So then what happens? I can't know it now. I'll probably almost made you afraid to cancel anything. Can we cancel those h's? Yeah, it's totally fine. There's no glue there. There's no Costco glue. That's just 9 times. Plus and minuses is the glue, right? There's no plus or minus there. You can buy just one. That's shopping in Save Mart. You can buy just one. That's fine. Just cancel out those h's. The answer's 9. And what that is the derivative, which you'll do in calculus. Mm-hmm.
Question.
Yeah.
What if the condition change? The h does not equal 0. What is?
What's that?
The different condition right there. When h cannot be
Oh,
0.
yeah.
What happen if?
Don't worry about that. We don't have to do anything with that. Yeah, calculus, they'll do a limit with that, and I'll let your calculus teacher explain all that to you. We don't have to do nothing about that. Good, let's try it now. They get a lot harder than this. That's just the baby one. Okay, so same kind of thing. They're giving me the toaster, the function, which is a harder toaster this time. X squared minus 4x plus 1. That means anything you plug in is going to go to those two spots, right? Anything I stick into that function is going to slide to those two x spots and have stuff done to it, right? And they're telling me, all right, here's what I want you to do. I want you to stick x plus h into that machine and work it all out. And then after you do that, I want you to subtract the entire f of x machine, and then I want you to divide it all by h. It's the difference quotient, the subtraction fraction. So try that. In fact, it'd probably be good for me to do the first step. Is that good? Does that make sense what I just did there? Let me add some stuff to that to make it more clear. Do y'all see that okay? Do you see how that's f of x plus h? All of this is f of x plus h, isn't it? It's the machine, the toaster, with x plus h put into it. That's the first thing I did is I plugged x plus h into it. So that x plus h showed up here and showed up here, didn't it? Right? I got to work all that out still, but that's f of x plus h so far. Is that good? And then minus all of f of x over h. Is that making? I'm glad to answer. I know that's the confusing part. That's what I was helping with after class. Can I help with that? Is that making sense? Do you see what I'm doing there? So I plugged in that x plus h into the function, which means everywhere you got x, there and there. I replaced x with x plus h. That's what it means to plug into a function. But including the 7, though, including the whole thing with the x plus h plugged in, and then the whole f of x subtracted over h. And then we just got to do a whole bunch of algebra, working all that out. That's where it'll become helpful to remember that eventually all the non-h terms will drop out of the top, won't they? It's just helpful because there's such mess now. So here we go. I've got to FOIL this, so it's going to be, can I skip a step? Okay. If I just, do you know if x plus h, which is what I'm doing right here, right? Oh yeah, wait, no, I shouldn't skip a step. Let me mention this. Yeah, I'm remembering now. Real common. It's really common mistake to write that. That's not true. Don't write that. My daughters wrote it almost all year long last year as I was tutoring them in pre-calculus. Not all year, all semester. Anyway, they kept writing that, and I kept saying, no, still not true. And now one of my daughters swears she never did that before. Anyway, they did that. So it's really easy a mistake to make, really easy. You can't do that. You got to write 2 of them in FOIL. You're going to get a middle term. You can't just square the first part, square the second part. That's not true. It means write 2 parentheses and FOIL the whole thing. Real easy mistake to make. So now, so you got to come down here and you got to actually do like that. Does that make sense? So you got to go x squared plus xh plus xh plus h squared. See how you get a little more to it than just x squared plus h squared?
Yeah.
Is that good? So watch out. Just practice. It takes a while. Like I did my daughters. Took all. By the end of the semester, they were finally getting it right. So you just got to practice, practice, practice. So then this distributes minus 4x minus 4h plus 7. So that's all this is that. And now for the other part, the minus x squared plus, I'm distributing this minus sign now, minus 7 all over h. Is that good? You see all that mess? Now what are we expecting to happen here? All the non-H'ers drop out. So I'm just going to cross him out. I don't know where, but he better. Or I've messed up. He doesn't have an H, right? He better drop out. Sure enough, there he is. There's his match. Right? Now this guy has an H. He can hang around, he can hang around, he can hang around. He better go away. He doesn't have an H. Does he? Yep. Sure enough, there's his opposite. He can hang around. 7, you better go away. You don't have an H. Yep. There's his opposite. See how all the non-H terms canceled out? They always will, unless I messed up. So what's left? What's xh plus xh? Good, because you add the ones in the front, right? So it's 2xh plus h squared minus 4h. Is that it? Yeah, over h. Now, I probably got you scared of canceling. Can I cancel these h's? Good. No. Plus, minus, Costco glue. It's all glued together up there. So what do you do to get around the Costco glue problem?
Bring it out.
You bring it out. You factor out the h on the top, because that makes it times, and that can cancel. You see, that's why we're so into factoring, because it gets around that Costco glue problem. Now you can cancel those, huh? Because that's times. That h is times, so he's not glued to anything. See the deal? So we're left with 2x plus h minus 4. Done. Is that okay? So for sure on exam, and this it won't be that easier one. It'd be this one. Probably the problem almost identical to this is on our first exam. Does that
And then on
make
the homework
sense?
we have a x cube one too.
Oh, yeah. See, I probably won't give you one that
It's
hard.
1 or 2.
That's usually my exam questions are like mid-level usually. So yeah. So we good to there? Any questions I can answer on all that? That all making sense? Yeah.
You have to put that part where you times the top by h at the bottom.
Yeah.
Oh, did you mean you just looked here and you just cancel?
Yeah.
That's totally fine. Yeah. Yeah. If you know that shortcut, what it's going to do is take one from each of these guys, huh? That's great. Yeah. That's good.
I wanted to try it about going into trivia.
Yeah. So talking about the area of a triangle is a function of height and
Based on type over.
what is it saying? Area of a triangle as a function of height, h, if the height, okay, yeah. So anyway, so you know the area of a triangle formula, right? What's the area of a triangle? 1/2 base times height. Remember that old formula? You get a 3x5 card in the exam. You can, if you're a little rusty on some of those, just write that down. Anyway, so now, here's the trick about what they want me to do. What they're saying is, basically write that. Good so far, but they're giving me a special rule here. It says height is twice the base. In other words, h is 2b. That's what they're saying in these words here. Height is equals twice base, 2b. So what does that mean? Take that and plug it in for h, huh? Does that make sense? 1/2 b, and what goes in the h slot? 2b. Does that make sense?
Okay.
And then the 1/2 and the 2 just cancel, and we have b squared.
Oh.
They probably said it in a fancy way.
Okay.
Does that make sense?
Yeah.
That's all they want. On that. Oh, and they want you to say a. They want you to put a b here and a b squared there. Is that confusing that I put that? That doesn't mean times. Remember, that means plug into the function. That means area is a toaster. It's a function of base, meaning plug in a base. I'll tell you the area. That's what that means. So that means plug in b, and the area is going to be b squared. For a triangle whose height is twice its base. That's true. All right. I want you solid as possible with that. So let's do that one. Yeah, 31 has x cubed. I'm not going to put x cubed on the exam. So the homework goes a little more than I'm going to do on the exam. So I usually go mid-level. So, all right, so 3x squared. You'll see when you see the practice exam. 3x squared minus 7x plus 2. So there's the machine. This one's slightly harder than the last one. So this one might be on the exam. It's harder because it has a number in the front here. That makes it a little bit harder. So it's pretty much like the last one though. So what do they want? The same old thing. They want, f of x plus h minus f of x over h. So let's use that for our last couple minutes there. So let me do the first step with you. Okay, everybody get to there so far? So that's x plus h plugged into the function, and then subtract all of f of x. Right? So the whole thing with x plus h plugged in, subtract the whole thing with x. It's always what we're doing on the difference quotient, the subtraction fraction. Then you got to work all that out, and we don't have much time. So it's pretty painful. When you got a 3 in the front with this whole thing, I would just let the 3 sit there. And then it's just x squared plus h squared like that. No. I hope that's becoming more and more. I'm going to try to do that 100 times after seeing my daughters do it for so often. I know it's easy to say, no, it's not that again, right? It's not that again. It's 2 parentheses, right? You can't just square them. It's 2 parentheses. So you got to write 2 parentheses like that and FOIL all that out. This guy's got to distribute minus 7x minus 7h plus 2. And then minus 3x squared plus 7x minus 2 all over h. Like that. It's a lot of messy algebra. And then here's a part that gets people a lot of times. Let me help with that. Right here, this x plus h. I would FOIL that first. Just let the 3 sit in the front. Let me say it this way. You could take the 3 and multiply into just the first one and then FOIL. What's not allowed, the only thing you can't do that's wrong, is to take the 3 and distribute through both of them. That's actually wrong. You can't distribute through 2 parentheses. That's double distribution. You can't do that. So anyway, just as long as anything you do other than that's okay. Probably easiest is just go ahead and do the FOIL. Let the 3 just sit there and do the 3 through the answer. So boom, 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 boom. So you're going to get x squared plus xh plus xh plus h squared minus 7x minus 7h plus 2, and then all the other stuff, minus 3x squared plus 7x minus 2 all over h. Yeah, I'm out of time, aren't I? So that's good enough. I think you can get it from there, right? And just keep on going. All the non-h terms should drop out. All right, so we did finish 2.1. So 2.1 will be due tomorrow Wednesday? Wednesday at 11 a.m. Have a good day.
I find these fun.
What,
Like,
right?
Yeah.
Right, 'cause- yeah.
That's why I was urging for